Yeah. All right. Welcome to the Jug meeting today. I realized as I was preparing slides for today's talk that actually this marks our first meeting in our 4th year of doing the Jug. So we've now successfully been doing this for over 3 years, 3 full years, which is, I think, kind of exciting. And we've come a long way since then. Now we're broadcasting on YouTube Live and all kinds of other stuff. So, agenda, same as always, we're going to do an introduction. I've already kind of done that. Statement of values, review, meeting schedule, news. We're going to talk about JavaFX today and then have time for questions and discussion afterwards. So we're glad you're here. Please sign the attendance sheet. Very important because we're trying to clean up our email. So put your email down if you would, please. So who are we? Mike Kelly, he's in B24, and I'm Andy Neprosh, I'm in A21, and Emily Rounds from A33. Why'd we organize a Jug for NSWCDD? Because we wanted to have a place to discuss common issues related to Java, meet people who are doing similar work, and potentially increase software reuse and improve Java development skills. Our mission statement is providing a Java software developer community that improves developer productivity, reduces duplication of effort through reuse, and fosters innovation through constructive dialogue. Values: mastering Java fundamentals, software development best practices, exchange of ideas, and fostering innovation. We always meet on the first Tuesday at 1 o'clock. So here's the news for today. Oracle, in its ensuing saga with Google, tried to open up a new appeals to the latest round, and they were shot down. So I don't know what's going to happen now. Oracle, part of the reason why Oracle bought Java is because Sun promised them that they'd be able to sue Google for like half the money that they paid for it. And so far that's not working out too well for Oracle, and Oracle really, really likes money. So I don't know if this is going to go to bed or not anytime soon. But so far it's not looking good for Oracle on this. In other news, Google Web Toolkit 2.8 is going to be released soon. I don't know if anybody's used the past versions of the toolkit. 2.8 will incorporate Java 8. What Web Toolkit is it lets you write Java code that gets converted to JavaScript for use on the web. It's actually pretty cool. Most of the people that use it really like it. So everybody was kind of concerned because there hasn't been released in about 4 years that this was just going to get abandoned, but Google has announced that they are indeed keeping it going, and this is proof of that. Java 9 has been delayed again. It was supposed to come out during Java 1, which was 2 weeks ago, but they're not ready yet. So they're saying probably July-ish of 2017, but at this point, who's to say, because it was supposed to come out 2 years ago, I think, in 2015. I think the end of 2015 originally, so I guess that's only a year ago, or early 2015, I don't remember. It's been a while, but it keeps getting delayed. Java 8 EE was also delayed. This one's delayed to the end of 2017, and they're dropping stuff from it, from what they were planning on putting in, so that they can actually get it out hopefully next year. So some people are upset, but most people agree that what they're dropping is necessary in order for them to get it out. Another big news is Oracle just got rid of NetBeans, sort of. They gave it over to Apache. They're going to keep supporting some of their developers like Ertan for a little while. So we don't really know how this is going to play out. Most people think this could be a positive thing, but there are some that are kind of afraid of what it might lead to for NetBeans. But that's big news. Also, Red Hat made it so you can run Java on Microsoft Studio. I don't know how many of you have used Microsoft Studio. I used it in my hobbies, and I don't understand why anybody would ever want to do that. But if you do, Red Hat has now made it possible. So more power to you. Another piece of news item that we literally just got minutes ago, or I literally just got minutes ago from Paul Anderson, is Java 10. Dang it, now I forgot what it is. What did he say about Java 10? Java 10 is going to have new, can you go to the email real quick?
He's going to call him up and ask him. Seriously. Got to speed dial. Java 10 will have value types.
Yeah, so Java...
Generic specializations like C++ templates.
Right, so it's going to have like C++ templates where you can use value types and generic specials or whatever. I can't talk today. So, moving on, this is JavaFX Demystified. Both Mike and I are presenting this one. Mike's going to take the first portion, so here he is.
Well, hello everyone. Glad everyone could be here today. We're going to try our best to go through some of the high-level architecture associated with JavaFX, and also give you kind of a tour of some of the details of components, the visual components, and also binding and how you can use some of these things. We've got some code examples as well. So this is what I'm planning to go over. I'll cover the first section and the last two, and Andy's going to hit the second one, which is the JavaFX UI controls. So before we jump in to any of the controls, let's take a look at the JavaFX architecture. It's actually pretty interesting. It hasn't changed a whole lot since JavaFX 2.0, but I thought it was worth just giving a little bit of a discussion to. So you can see here basically you have the Java virtual machine at the base. You've got the JDK API libraries and tools here. And then you've got Java 2D, OpenGL, and D3D, which is, I guess, DirectX for Windows. And so basically on the Macs, they use OpenGL, and on Windows, they use DirectX. So it tends to use whatever your hardware will support, and if it can't find anything, then it falls back to Java 2D, which is a software rendering. So you've got Prism and this glass windowing toolkit. And what's cool about the glass windowing toolkit is it actually uses the native UI thread directly, whereas old Swing applications, it had to actually do coordination between the event dispatch thread and the native UI thread. So for that reason, JavaFX tends to be a lot faster than the old Swing thread. So Prism here basically is using the hardware. It's up to render all of the graphics, and the Quantum toolkit basically ties both these pieces together and gives you, the cool API that you can use to run JavaFX applications. So this is kind of the structure of a JavaFX application. Essentially, you've got a scene graph, which if anybody in here has ever used Java 3D, this reminds me an awful lot of that. You've got a scene graph with a scene object at the base and then a hierarchy of nodes that represents your view. And so over here on the right side, I've got the stage. The stage is what actually displays the visual representation of what's in the scene graph. So you can think of the scene graph as sort of your logical representation of what you're trying to display. The stage is actually the rendered version of that. So you can think of the stage as kind of like, your frame or your window. And actually I have a little code example here. Jump over here to my Hello Earthrise. All right, so here's a sample. Let me zoom in here. Can you guys see that? Okay. All right. So this is a sample JavaFX application, very simple. You can see it extends application. So pretty much any JavaFX app is going to extend this application. And you see we've got a main entry point that simply calls application launch. and passes in the arguments. Launch is a static method of the application. Really, the only thing that's required is to override this start method. There's also an init and a stop method that you can potentially override as well, but start's the only one that's required. And essentially, in this case, we're just doing something really simple. We get the stage passed in as part of the method call to start, and then we're just going to basically get a message that talks about, the view of the Earth from the moon, and here we've got a text control. And I won't go into detail right now because I don't want Andy to go into some of this stuff. But essentially all we're doing is we're taking the stage, we're creating a scene, and associating the scene with the stage, and then calling show. And when we do that, where's my Hello Earth Rise? Run. It just basically shows this. And here we've got some transition happening where it's basically just causing it to scroll automatically. But a couple things to point out here. This visual representation here, this is the stage. Stage includes, I believe, the widgets at the top here as well. So you get kind of your standard frame like you did in Java Swing. All right. So I already kind of mentioned this a little bit, but there's the application class, which is kind of your entry point to the JavaFX application. So it has three methods that you really care about. It's got init, start, and stop. The only one you absolutely have to override is this start method because it's declared abstract in application. And in order to launch it, you just use application launch, and there's a couple of variants of that, but yeah, they're both static, pretty self-explanatory. The next class that we care about is the scene class, and this is literally the root of it all. This is the scene graph that I talked about a couple of slides ago, and this is the top-level container that manages all of the elements that get displayed on the stage. And all of the child elements of the scene have to be an instance of the node class. So node is kind of the base class for all of the objects that can be stored in a scene graph. Scene has a root property that typically is assigned to an instance of a group here, which basically just means it can hold multiple nodes. And once again, very similar to Java 3D, where you basically, you had to have a group where you could add a bunch of nodes to it. Otherwise, you would just have, a single node. So there's several different types of node classes. Some of them are just represent single entities, and others are basically just containers for other nodes. Stage class is what you see, and it contains the UI of the JavaFX application. So I think of this as being the visual rendering of the contents of the scene graph. It has its own top-level window, which, as I showed, had the control bar at the top, and it renders whatever you put in the scene graph. And here's a hierarchy for the node class that I mentioned. Once again, the node is the base of the hierarchy, and so you got several things that come off of the node class. So you've got some shape classes, which give you things like circles and so forth. You also have the JavaFX 3D, which is also part of JavaFX, the shape 3D, and then parent and region and pane control. These are container nodes because you can put other things in them, and controls are the things that you would tend to think of, like buttons and text fields and so forth. So the bottom line here, anything that's in the scene graph must descend from node. So even your own classes that you implement, you have to start there. All right, so main points. As I covered, your applications have to start with extending the application class and implement the start method. And the init and stop are optional. Sometimes you'll need those, but most of the time you won't. And the nodes are in a scene graph, which is displayed on the stage. and the node subclasses represent the actual visual components, and others just represent containers. And so these are just a couple of examples. Button is a visual component, and stack, pane, and group, those would be examples of container classes. So both of those types, they have different functions for building up this scene graph. Okay, so that's just a very high-level overview of kind of the architecture of JavaFX. Now I'm going to turn it over to Andy, and he's going to talk about some of the different UI controls.
Alrighty. So real quick about creating a user interface. So the picture that you see here is actually an example. You can get the code for it of a user interface that can be made with JavaFX pretty easily. So it's very powerful. It does a lot of stuff. So real quick though, there's kind of two flavors of JavaFX. There's JavaFX straight and JavaFX FXML. Essentially they're the same, but they're very, very different. So they have in fact, all of the same nodes, the same panels, the same controls that exist in one exist in the other. If it doesn't, it can easily be made to do so. But they're done completely different way. FXML is mostly kind of an XML, which is why it's FXML syntax. It has two separate things, and it introduces something called a controller. That's kind of complicated to new users to FXML. For new people to FX, I highly, highly recommend, and every site I saw, every book I've read about this recommends that if you're new to FX, start with just straight FX. Get used to straight FX before trying to mess with FXML, because FXML, I love FXML. I prefer using that over straight FX any day because I like it. But it's very powerful, and it lets somebody that doesn't really know what they're doing get into trouble very fast. So you need to kind of know what you're doing before you jump into FXML, because you can get into real good trouble real quick. In fact, if you don't know how to read the XML part of FXML, you can wreck your scene builder and be completely stuck and have no way to fix it. So
controlling the FXML, you highly don't find it.
Right.
It could not load.
Right, and you get weird error messages if you do silly things that are really hard to understand. So you really have to know what you're doing before you jump into FXML. But if you're going to make something large and you want it to have a lot of high detail, FXML all the way. It's so much nicer than straight FX. But know what you're doing before you get there. The main difference is FXML has a controller, which we talked about, and FX is just straight Java. And I'll show you what these are in just a second here. So containers. A container is something that you put stuff in, obviously. In this case, on the scene, it's stuff you'd put stuff in. So we're not talking about data. We're talking about actual pieces of your UI go into containers. Now, it's completely different than Swing. People that have been doing Swing that try to get into FX without forgetting about their Swing days and realizing that this is a new paradigm also get themselves into trouble. In FX, it's important to think of everything as stackable containers. You need to stack stuff. Stuff needs to stack. Now, this is completely backwards from what we've all been taught. We've been taught if you have things that are stacked 3 deep or more, then you're doing something wrong. In FX, if it's not 3 deep, you're doing something wrong. If you're 15 deep, you're probably okay. 30 deep, that's fine. I'll show you, actually. I'm going to show you. Well, I guess real quick, can somebody wave their hands over there by the... Hank, can you wave your hand? So, it'll kick back on in a second.
It's easier to see with the light.
Yeah, okay, whatever. So real quick, what I mean by stack is you wrap it inside of it. So you'll have different kinds of things stacked inside of each other. if you can't figure out how to get something to do what you want it to do in FX, you probably need to put more things in your stack. You need to have more containers there. In fact, as I was writing this, I realized something that I've been working on for the last month. I was trying to rack my brain figuring out how I was going to get it to realize where the middle of the screen is, and I was like, I'm an idiot. I just need to put another H box in there, and then I'll know where the middle is, because if it's a 2-item H box, it'll have the middle. So I just need to add an H box and probably 2 more anchor panes. So it's going to go even deeper, and I'll show you kind of what I mean in a second here. So the thing is with each container, you have to realize is they're designed to give their children the benefits. It's not about the container itself in most cases. It's designed about what are you going to give the container's direct children, not their grandchildren or whatever, just their direct children. So like an anchor pane or stack pane, grid pane, VBox, HBox, which we're going to talk about, they only give their benefits to their children. This is important to know. It's not about them, it's about their kids, just like with everything else in life. So, here's the first thing I want to talk about. Oh man, it messed up my text when we merged it. The first thing I want to talk about is grid pane. So I see this a lot when people are like, I'm working on this and I have a problem. I can't figure out what I'm doing wrong. I go there and they have one pane and it's a grid pane. And they're trying to do everything in there. And I'm like, why are you doing that? And they're like, well, I saw grid pane and I loved grid layout from Swing. So I was like, I'm going to use that because I know how to use grid layout. And grid layout was the best in Swing. And there we go. And then everything's all messed up. And they can't understand how to get stuff to work and how to do stuff. But they only have one thing, and it's a grid pane. Again, you have to get away from Swing. FX is completely different. So don't try to use grid pane. It has its place, but I barely ever use grid panes in FX. The times when you would use a grid pane are very few and far between. What it does is it lets you literally lay things out in the grid as the image shows. And if you are just using a grid pane to avoid having to use other stacks, you're really breaking the paradigm of FX. You're busting what FX gives you and what it's about. So I'm talking about this as an example of one that you really should avoid using. If you are tempted to use it because you remember it from your Swing days, that's bad. Anchor pane is probably the most used. It's typically the most used, actually. It's great for anchoring stuff to the sides, to the walls of whatever it fills. So when you add an anchor pane to something, it takes on it fills whatever its parent is, and then it gives its children the ability to latch on to none to all 4 walls. So the image that you see here is actually how you latch it or link it to the walls in FXML and Scene Builder. And that's all zeros. So if you have something set like that with all zeros, the child's gonna completely fill the anchor pane. So why would you use the anchor pane then if it's gonna completely fill it? Well, the reason why is because anchor panes are great for resizing. If you didn't use that and you didn't resize it, when you shrunk the main screen and the anchor screen shrunk, it's just gonna clip whatever is off as you resize. But if you use an anchor pane, the anchor pane says, oh, well, now my walls are here, so I still need to anchor it. It's going to shrink everything inside of it. That's the main reason why people use anchor panes, because they're great for not only for positioning stuff, but for resizing. It handles most of the resizing in JavaFX, so that is why it gets used the most. Because nowadays, most people want their stuff to resize nicely. So again, it only deals with its direct children. So what this means is you can have an anchor pane, another kind of pane, an anchor pane, another kind of pane, an anchor pane, another kind of pane. Not unreasonable. And this is why it's quick to get 15, 30 deep, because you'll have things stacked inside of each other. So the next big one that should be used the most is HBox and VBox. These guys are brand new to JavaFX, and they're extremely important and helpful. these guys are your friends. Use them a lot. A lot. I cannot stress that more. It seems pretty straightforward, but you don't really realize the power of them until you understand stacking it and how you can stack them in to get what you really want. So just real quick, an HBox, it organizes things horizontally. That's why it has an H in front of it, and a VBox, of course, does things vertically, hence the V. If you put a VBox in an HBox or an HBox in a VBox, then you get a grid pane, and it's actually a much more usable grid pane than the grid pane. So some examples, the first image just kind of shows you how HBoxes and VBoxes work, and the second one is several HBoxes inside of a VBox. So you could put like 4 buttons in each one of those, or 4 text fields or whatever in each one of those HBoxes, and it will line them all up nice, and everything will be good and pretty, and all will be well, and you will have a grid like you wanted originally, but without all of the messiness of grid pane. Finally, I want to talk about stack pane before I start showing you guys stuff. So, stack pane, the reason why I want to talk about it is because it's the second most abused item in JavaFX. I don't know what it is about stack pane because I don't remember there being a stack thing in Swing. It's been a while since I've done Swing coding. But for some reason, people see stack pane and they want to use it. I don't know why. I see really bad stuff a lot of times with stack pane, and here's a hint: your stack pane should never be the bottommost item in a stack. It just should not ever be that way. If it is, you did something wrong. So what a stack pane does is it lets you stack things on the Z-plane, so coming out of the screen at you. And everything that gets added goes on top of whatever was there before, and it just keeps coming out. I don't know if it has. I've not messed with stack pane that much. I don't know if you can reorder stuff. I'm sure you probably can. I know you can through manipulating the ads if you really want to. But so the image, it shows a flow plane of just 3 boxes of different colors, and the flow plane, which is another kind. There's tons of planes, and I'm not going to cover half of them. Not even a quarter of them. But the flow plane will just stack things to the right of each other. So that's the flow plane. And then once it hits the end, it will go down to the next line and keep stacking them. But the stack pane puts it on top of each other. I have that image with both so that you can just kind of see those are the same boxes, and that's how the stack pane works. They're all stacked up on top of each other. So let's talk about controls real quick, and then we'll do the demo. Essentially, the controls are the same. There's a few that are new. They're much easier to use than they were in Swing. You have to do so much less coding to use them effectively. But in out of the box JavaFX, they're essentially the same. It's the things you would expect, like buttons and hyperlinks, toggle buttons, lists, list views, tables, those kinds of things. Scroll views, progress bars, activity bars. It's essentially the same stuff we're all used to from Swing. So there's really nothing new there. If you want new stuff, though, then you can get something from Gluon called ControlsFX. And it's free. It has a license that allows us to use it. It's open source. And it adds a lot of really amazing, cool controls that are bug-free. At least that's what Gluon says. I'm not running in any bugs yet and using them. But it adds things like one thing that we're using in a project I'm working on is a double or a range slider, which actually was shown to us last month. For those of you who were here last month, where it lets you have a minimum and a maximum on a slider, and you can do both, and that's pretty cool. And trying to write that yourself is actually pretty complicated, but you can just get it in ControlsFX, and they have, gosh, probably like 40 or 50 really cool, thought out controls that you can add. So I wanted to get a screenshot of their stuff, but I couldn't find one, so I'm sorry. So let's real quick do a, let's see. What's this? All right, so I'm just going to start it. I did have one set up, but it doesn't work. It didn't transfer over well for some reason. I guess I missed the piece when I copied it. So what we're going to do instead is we're just going to start a new project real quick, which is really easy to do. So I'm going to do FXML. So this is NetBeans. I just did open new project, JavaFX, FXML application, and do next. I'll just let it be called application 2. So this is going to give us this. So if in FX, if you click on the FXML thing and you have Scene Builder loaded, it will open it up automatically. At least it should. It did. Yeah. There we go. So this is our application that we got straight out of the box. It has a silly button. If we run it, which one is? Nope, that's not what I wanted. Where's your NetBeans icon? Oh, it's hidden.
Scene Builder integrated with NetBeans now, or you set that up?
What's that?
Scene Builder is integrated into NetBeans now, kind of as a plugin now?
No, if you have you can link it in NetBeans. If you link it in NetBeans, it will find it. So I'm just gonna do it like this. So we'll run it real quick so you can see what it does. The one outside of the box, and it just has a button that says "Click me." When you click it, it says "Hello World." So that's what you get straight out of the box. Well, dang, now your icons are so much different.
They're on 2 lines, so you have to use the arrows on the right. Yeah.
All right, so here's what we're going to do. We're going to mess with this now because I want to show you guys the stacking that I was talking about. So what I'm going to do really quick is, well, there's the label here that's hidden, right? So we can see over here, this is kind of the main anchor pane. These 2 guys are underneath this, so they're in that stack. So I'm going to actually just get both of them. Actually, no, I don't want to do that. I want to get the label and move it out of the way real quick. And then I want to get this, make copies of it, and just paste a bunch of them. All right. So they're all nice and stacked up for me because apparently this is a stack pane.
Is it an anchor pane?
Yeah, it's an anchor pane, but I mean the actual widget that they used. Anyways, so now I have a whole bunch of buttons, right? But I don't really like how they're organized, so I'm going to take them and I'm going to right-click and say Wrap In, and I'm going to put them in a grid pane just so you guys can see. So that's what it did for the grid pane. So now it's kind of wonky. It just kind of threw them in whichever one was closer. But, you know, that's cool. So now I'm going to just move one here so it actually looks right. So that's the grid pane, and yeah, it has its use and it's cool. Dang it, I want the. So what we're going to do though is, now, why isn't it letting me unwrap? Oh yeah, that's right, you have to do it on the parent. So I'm going to just get rid of that and put them all back. So now what I'm going to do is I'm going to get half of them and put them in a V box. Move them kind of off. Get the other half. Put them in a V box. Then I'm going to take both of those V boxes and go ahead and wrap them in an H box. So now we have the same thing as what the grid pane was. The difference is this is actually much more useful than the grid pane. I know it doesn't seem like it, but when you start getting in and coding it, trust me, it's a lot nicer. And we could do other stuff, like if I want to copy this whole V box, paste it. I don't even have to put it over there. I don't know why I did that. I can actually I just move it. I could just move it right on into the H box. Now he should go in there. He didn't go in there. There we go. Okay, except for I got the label in there somehow too. So So yeah, see now, if I had done that with the grid pane, that would have been a pain in the butt. But as soon as I removed the label, it snapped back together. And I could put spaces in here and do whatever I want. But basically what I'm trying to show you is all of these are good. So how, you might say, well, how is that really helping me? Well, what if I wanted to so if I run this, always the biggest thing with using Scene Builder is you have to remember you have to save it before you try to run it, or else it doesn't get your changes. So if I try to run this now, we can see it has all of them. They all just do hello world, and I guess it puts it out down here too.
Can you go back to where you just were?
Sure.
Show them on the code and right click on the XML. Not that, the actual NetBeans.
Okay.
Sorry.
Okay.
Yeah, go right click on the FXML.
Okay. Yeah, you want to see the FXML code?
Just hit edit.
Yeah.
Right click and hit edit. So
Right.
put it up in there.
Right. So you can actually look at the FXML code. So this is what it looks like. You can see they're all kind of stacked in as a XML format. But
you can make changes here.
you can make changes here, and they will show up in the Scene Builder.
And the reason why I asked you to do that is because all of us have made changes in here and forgot to hit save. Went back to Scene Builder, made a bunch of changes, hit save, and it doesn't work.
Yeah, it's very important to save when messing around with Scene Builder both ways. If you're going to change this code, you have to save it before you mess with stuff in Scene Builder. Otherwise, Scene Builder will just clobber anything you changed in here. And if you don't hit save on Scene Builder, then your changes don't make it into the code. And when you go to run it, you're like, what the heck? Why isn't my new stuff there? Oh yeah, because I didn't hit save. Yes, this happens a lot, and you learn real quick to save a lot. It's like playing games. Save. So while we're in here, let's look at the controller too. Just so you can see what a controller is real quick. So this is the controller. So one thing that you'll notice is it has these FXML tags, like right here. So this is for the label. This is another, I'm going to talk about this in a bit, but this is another place where people get into trouble a lot. Notice this, we just saw it run. All of the buttons did something. This is all the code that's in my controller right now. Normally your controller gets huge. It gets huge really fast. So don't worry about it getting huge, but to kind of keep the hugeness down, realize not everything needs to be in the controller. I don't have any of those buttons. I have 9 buttons now, and not a one of them are in the controller. The controller has no knowledge of any of them, and it doesn't need to. It has this action event that the buttons all call through the FXML that let them do what they need to do. There's no need for them to actually be in the controller. The only reason you put stuff in the controller is if it needs to be changed by the code. If you need to change it for whatever reason, it's got to be in the controller. If you don't put it in the controller. Just leave it out. So the reason why the label's in here is because why? When you do it, it's supposed to set the text to hello world, and it changes it. It gets changed. That's why it's in here. But this is another place where people make mistakes, because if you make the label, and I'll show you how it is on the Scene Builder side too, but if you make the label here and give it a name and there's not a matching one there, you get a really weird error that is really hard to understand, the error output that comes out. So typically, if you're getting a strange error, check and make sure all of your FXML tags match actual IDs in the FXML code. So I'll show you the code part real quick. So this is the label. If we go down here, except for I can't because it's off the screen. Oh, yeah, it was there. Okay. If I go down here to code, the FX ID, that's what I was talking about. This is label, which is what it was in the other one. They have to match. And don't try naming 2 things the same thing. Very bad. Very, very bad. Don't think you can name two things the same thing and then control them both the same in the code. It does not work. It crashes and it's just bad. So don't do that. Everything has to have its own unique ID. Even if they're identical objects that are supposed to behave the same way, they have to have their own. But if you look at the buttons, they don't. Actually, the buttons do have an ID. That's kind of weird.
They all should have.
Yeah. You don't have to give them IDs though. If I remove all of these IDs, since nothing's happening with them, it'll be fine. But this does bring up a good point. It is okay to have things in the FXML have an ID and not have a matching one on the controller side. That is okay, but the reverse is not true. If you have the add_fxml tag and you don't have something with that ID, then bad things. So okay for IDs with no FXML tag, not okay FXML tag, no ID. So it automatically gives them unique IDs when you copy them, which is why this one was 1 and then it got, or it was 3 actually, and then it got a copy made so it tagged a 1 on. So it's 31 now. It does weird things like that. But basically that's the gist of it, and we can add other wrappers. We could wrap this whole thing in other stuff if we want to. One thing we can do real quick to show you is if I go to the layout, actually on this guy, this is the anchor pane thing. Now I'm working on the HBox right now. See the HBox, but because it's the child of the anchor pane, it has this. If it wasn't in the anchor pane, it wouldn't have this. This would not be here. So this is reinforcing what I said earlier. Everything is, all the panels are to give it to their children. That's their goal, their purpose. So I can change things around in here. I can actually make things kind of weird by, let's force it to stretch all the way out and see what happens. Okay, so what happens is HBoxes and VBoxes are meant to stretch, so it's actually just going to justify it however they're currently set up to justify. What you could change that so they center automatically. But the good thing about this now is if I shrink it, it's all going to shrink. If I run it and shrink it, everything is going to go, because now it's linked to the anchor pane. So if I run it, which I can't use my trick anymore since I shrunk it. So now if I shrink this, well, I did not save it, you're right. Yep, this is a problem. Yes. So now I have to kill the ones that are running because for whatever reason NetBeans won't let you run too many. So let's try this again. So they're all, but you can see it actually does try to shrink them now, whereas if they weren't linked it would not do that. So any questions, anything else somebody wants to see?
And how would you stretch them out?
You can actually do that really easily. There's you can give them a property to make them fill as much space as they can, and it's actually you could do it this way too, but I think you have to put them in another thing that makes them do that.
I think it's up on the top end.
Yeah. And actually, I think you have to do it on the HBox. Node orientation. I can't. Yeah, so, but this. Yeah, you can make them use the whole line. I know there is a way to do it, but I think you might have to wrap them in something else to do that. But you can, if worst case.
Oh, that's because you're on the HBox. Click the button.
Yeah, click the button. I think you have to actually be on the actual controller.
And some of them do, I know, stretch out.
Yeah, go up.
Yeah. I don't know that buttons do. I know all the text boxes will automatically expand. But another thing that we could do to force it to happen is actually we could wrap each one of these in its own anchor. Actually, let's just do the V boxes. So we'll wrap each V box in an anchor pane. So now, this is actually probably the right way to do it. So now each one of these are going to get wrapped in an anchor pane. So now what I can do is I can go to the V box and tell this one that I want it to go to the left side, and tell this one, at least this should work. It might not though. Let me go. Nope, it's not working, dang it, because of the H box not stretching. Anyways, it can be done. I don't remember how to do it right now, but I have done it. So, but it can be done. You can add padding to them too and stuff like that between them. But anyways, so that kind of shows how you really have to think about the stacking and how you do everything with this. It's the stacking that if you can't do something, it most likely needs to be in a container that lets you do to it what you want to do to it. So any questions about this then? Any other questions? All right, we'll move on real quick. Close this down. Back to the presentation. Which one's the presentation? All right, so CSS. JavaFX is designed to use CSS. You can do it without using CSS. It is possible, but it's much harder and it's really not recommended. It makes using CSS, I mean, they've integrated CSS in such a way that it's super easy to do. Even if you're a noob to CSS, you can pick it up real quick and be going strong with it in no time. There is one thing you should know though, it's not quite standard CSS. They have their own special tags, and you have to use their own special tags, and they all start with -fx. So it'd be like -fx, -background, -color, and then whatever color you want the background of that, whatever you're styling to be. So that's one thing to know is FX has its own. You can go on Google and find out all of the CSS tags for FX. And there is a bug. I meant to show you guys it, but I forgot. There is a bug that if you have a panel, say, like for instance, if you have any of the panels, like a V-box, a stack pane, a anchor pane, whatever, and you want to make that panel have a special effect, or what's it called? Yeah, special effect. Like for instance, if you wanted to have a drop shadow for the whole panel itself, if you try to give it that panel through the FXML, it will actually give it to all of its kids, and that's because the panels are for the kids. So it will make all of its kids have drop shadows, but you really wanted the panel itself to have the drop shadow. So you can get around that two ways. You can either do it to its parent, which will make it have it, but if its parent has more than one thing in it, then that's not ideal. So actually, how most people get around that is you just hard code the special effects. They're actually easy to do in FX too. So just hard code those. Don't try to use CSS for that.
You just nest another layer where that's
Yeah, or you could do that, but typically though, I find you're safer and better just hard coding it. So because you can mess with the code anyways that way instead of using the presets.
There's also another bug with the CSS style sheet for the FX for font. If it is not a standard font within the Java community that's sort of standard on your operating system, one that you've added, it doesn't quite know how to operate in that setting. So you have to make stuff nested instead of putting them all in one line. And once you become more familiar with the CSS style sheet, you'll exactly know what I'm talking about. But like sizing, color, and font, you can't put that all in one line. You have to break them out ×3. So just know that that's also there if you're having to deal with particular fonts from your HSI folks.
And in the CSS, you can also, I mean, most people who do CSS a lot know this anyways, but in the CSS, one thing that's different than it was in Swing is you can actually stack colors. So if you want, now I'm colorblind, so this is extremely difficult for me, but if you want, say, green, then you could actually put a blue and a yellow and it'll show up green because they'll stack. So in the CSS. You could have two different colors. If you don't remove one, then they're going to stack and it's going to be green. So yeah. So animation, I'm going to show you guys the ensemble tool. I don't know if anybody's seen this before. Now I know I had that. This is it here. So this tool actually kind of was abandoned like a year or so ago, but it's still around and it's actually really cool. I like it a lot, so I don't know why they abandoned it. But it does show things like in animation. It has all kinds of different stuff, different samples of things you can do with JavaFX. But I also like that it gives you the source code for everything that you can do, so you can look and see exactly how to do what I saw happen. So for like animation, it has things like just an interpolator. You could do transitions like, come on, move to this one. What's going on here?
Yeah, just a refresh button.
No, I think it's locked up. Actually, I think it's because I let it sit too long. Huh. That's interesting. Okay, well, let's try starting it again. Let's see. Oh, I know why. Because we didn't copy it over. Let me just get my, don't freak out people, have a thumb drive, it's going to be okay. So, I know what happened now. The code is on the thumb drive and I pulled the thumb drive out. And so of course it's not going to run without the code. So, let's just try that again. Alrighty, so here's like a basic list of a lot of the different things, and you can just mouse over any of them and see kind of what they do. But these are different animations that are available. So you could do, you can go into more of them, like have something like this, and again you can see the source code, and the source code really isn't that big to get it to do that. That's actually one of the bigger ones, but you can do stuff like that, and it's usually fairly smooth. They actually, I think, but they have a lot of different samples in Ensemble, and it shows what's possible with FX. So you can get the code obviously to do this too, and this is FX drawing all this on a picture. All of these fireworks are being done by FX. There are charts, lots of charts that you could do. You can use right out of the box. Different kinds of charts. This doesn't have some of the newer stuff in it, but you could do all of this. So if you want to really see get kind of a feel for how, so this shows how an HBox works. If you want to get a feel for how FX works and how to do stuff, get Ensemble and just mess with it. It has a source code there, so it's a great way to get ideas of what's possible and to get code on how to do it. But as you can see, FX actually handles animation really well. So if we look at the samples, I think that's the best. But it handles all of these animations really well. They're smooth, they're nice. If you try doing these same things on Swing, I've done it, it's ugly, it's messy. They kind of jump and skip, and it's really hard to get things to go smooth, especially if you're doing more than one thing, like spinning a box while moving it. So, cool stuff in Ensemble, and you can still get it. You can actually just use it through your web browser too, though I don't know that I would do that these days with Java in its state. So, In the interest of time, though, we're going to move on back to the slides. So I was going to just talk briefly about this, but I think Mike's going to talk about it more. But basically, I was going to show you a demo on this too. Actually, that demo doesn't work because I didn't get all of the code for it. So it's easy to do. We could do a whole session on just swing in JavaFX, but I think that'd be kind of boring, personally. But you can do FX in swing and swing in FX. I don't recommend doing that unless there's a really good reason. Like if FX unfortunately doesn't yet handle OpenGL. So if you want to do OpenGL stuff, you need to use a swing window to do that. That's the only reason I would ever use swing in FX at this point. Even if something was already in swing, I'd rewrite it in FX before using it. So real quick though, see, these are some gotchas to avoid.
With the swing and FX thing, when I play with them together, they don't do modality to each other properly. So, you know, an FX panel is the parent to a swing one, and you make a modal, they can go behind, and vice versa. They don't work that.
I've only ever messed with the two combined in NetBeans platform, and the NetBeans platform handles all that, so it hasn't been an issue for me. Have you had an issue? You probably do it all in platform
I know
too.
there's some weird things when you try to mix them. I hadn't heard about the modality, but it doesn't surprise me.
Yeah, yeah. What's that?
That's what I'm saying, but you don't have that issue when you use Oracle.
Yeah, see,
Those are switch points wrapped in FX.
we have.
Yeah, probably. I've heard that putting FX in swing is much worse than putting swing in FX. So,
Whirlwind is not an FX.
right, it's not, because Whirlwind needs OpenGL.
Right, so you have a Whirlwind app and then pop-up and FX, pop-up window, just its own little window. You can't make it modal to that back-end swing application. It can go behind. At least what I found. I wasn't able to find a way to make it work.
We can do it because we're not using Whirlwind as its own window. We're wrapping that in FX.
Yeah.
Did you not wrap there?
She's talking about FX and swing. You guys are doing swing in FX.
Yeah.
And it's
the other way, right?
Yeah, it works. Swing in FX works much better than FX in swing. I do know that for a fact.
That's the way you want to go.
Right. So real quick, some gotchas that we should talk about. These are things I've seen people do that are kind of new to FX, and I just want to, and I've talked about most of them already, but I just kind of want to reiterate it. So again, I showed you this. Not everything needs an ID and an add FXML tag in the controller. If the FXML can handle what you want to do to it, just let it, because you can put the CSS and anything else you want in the FXML and not even have to worry about it in the controller. It's better that way, otherwise your controller gets really convoluted and crowded fast and it gets confusing. Remember that because grid pane sounds like swing's grid layout, it's not the same, and you shouldn't use it because it sounds familiar. This is a big one. I see tons of people do it. Another one that I see is in swing, everything, it seems like, hey, if I wanted to do that, I needed to make my own managers to handle like its different states and stuff like that. That is not the FX way. You can still do it if you really want to, but you're making life much harder on yourself if you do that. So it's better to actually just use FX because there's something already there to let you do whatever it is you want to do. Which brings me to my next point. My biggest complaint about FX personally is I have sometimes racked my brain for like hours trying to get something to work. Like something that I thought should be simple and should work straight out of the box, but I couldn't figure out easily how to get it to work. And I've got something finally that's all kludgy and glued together, and then I'm so happy I go and show like Mike or somebody else, hey, look what I did. And he's like, oh, you know, there's the FX thing that will just do that in one line. And I'm like, son of a, spend like 8 hours on this. So you got to get the Google Foo going really good. It still seems like it's hard to find out what FX can and can't do. I think people are still kind of learning it. And so figuring out what it can and can't do is still kind of hard. But chances are, if you want to do it, there's a way to do it really, really easily through FX. You just got to figure out how. So that's my portion of this. I'm going to turn it back over.
So you're saying Stack Overflow doesn't have too many questions answered?
They're getting more and more. It's getting better. My favorite site actually is a site called Java2S because it just has example code for everything. So I usually go there first.
All right, well, let's, Light, come on, Light. I'm going to try to get through this as quickly as possible. I don't know if I'll be able to cover as much as I wanted to, but I'll do my best. So I wanted to talk about properties and binding. That's one of the key features of JavaFX, one of the things that is just really awesome and cool about JavaFX. And so I may not go into as much detail as I wanted, but I don't want to keep you here forever. So basically, the whole idea behind properties and binding is it enables an application's UI to stay in sync with the application state and model. Now in Swing, we use listeners to accomplish this, and that's what we're used to. So this might make your head hurt to watch the magic happen with binding. But essentially, you can have property values that are bound to other property values. So basically, in one line of code, you say bind this property to another property. One of the values changes, and boom, the other one automatically changes. So your text box automatically changes when you update a property. It almost seems like magic, but it's actually becoming very common in a lot of the web frameworks today. Model view model is very common today, and that kind of uses a lot of the same principles of binding. So the other thing that's interesting, it doesn't necessarily have to be just a straight binding. There can be complex relationships between them. So you can say, well, whenever this property changes, I want the value to be 2 times that value. You can do those types of things, or Boolean logic, or very interesting relationships that you can set up using nested bindings. Binding can be one directional or bidirectional. So an example would be if you've got a text field that when you update it, you want something else, another text field to update, and you only want it to go one way, then you would do a one-way binding. But now if you have 2 text boxes where if I update this one, I want to update the other, and vice versa, that would be a bidirectional. So that is awesome, because I remember trying to do that exact same thing in Swing, and it was pretty darn complicated, to try to sync up between 2 text boxes, and all you wanted to do was just make them have the same value all the time. So this that alone, it can save a lot of time for doing simple things that seem like they should be simple, but are not when you try to do them in Swing. So let me just jump over here to my next example. All right, so here is a bidirectional. You guys read that?
Yeah.
All right, bidirectional binding example. So let me just throw a breakpoint in here, and yes, that's what I want to run. All right, so in this case, we're using 2 properties. We've got 2 simple string properties. I'll get into what those classes mean in a minute, but basically we're creating two string properties, prop1 and prop2, and we're going to call a bind bidirectional on prop2, which basically means that we're going to link those 2 values. So if you change either one, the other one gets updated as well. All right, so now we're created them. Now in these 2 cases, we're calling isBound. Now, you might be saying, why is that false? That doesn't make any sense. We just bound them. Well, turns out the isBound only returns true if it's a one-way binding. Because if you have a 2-way, it does not prevent you from calling the set method on either one of those properties. Whereas with a one-way binding, once it's bound, you can no longer call the set method. So I'll get into that in a little bit, but I just want to show you here. So we set property 1 to prop1 says hi. Now we print out property 2, and not surprisingly, it also says the same thing. Now we're going to update property 2 and just tag on property 2 says bye. So we print that out. And yep, that's the property value for 2. So now we print out property 1, and voila, it has the same value as property 2. So basically we've shown that we can set either value and it will automatically update the other. So once again, when you get into using these with some of the widgets, the controls, it becomes very powerful because you can very easily synchronize your text box with a property that is kind of your model property, and have that automatically synchronized with other widgets in your GUI. So doing that with Swing used to be a major pain. So it's now much easier to do that. Okay.
Which is why you don't need managers anymore. Use binding instead.
Yeah, so binding gives you a lot of power for very little work. All right, so this is kind of a hierarchy of the property, and the base is observable. So here the base of it all is called observable, and this is an interface, and it allows you to essentially add and remove invalidation listeners. You say, well, what's an invalidation listener? Well, all that is basically a listener that gets notified when you need to recompute a value. Doesn't actually compute it, just says, hey, something happened and now you need to recompute your value. Well, if we go down the chain one more, we get an observable value, which actually gives you another method called getValue. Well, this means that instances of this class actually have a encapsulated value. Well, now we can add change listeners. So if you're like me, you're saying, well, why do you need an invalidation listener and a change listener? Well, it basically allows you to do what they call lazy evaluation. So you can basically notify an observable and say, hey, the value that you had is now invalid. But the guy's like, okay, I don't care, whatever. So next time, though, when somebody says, hey, give me your value, oh, okay, you need it. Now let me recompute it. That's called invalid. That's called lazy evaluation. So it's basically allowing you to get notified when you need to recompute something, but then delay the actual computation until you actually need the value. This saves you CPU cycles, essentially. So it's becoming more and more popular these days. Yes, sir.
So if you have a window that was holding value, the window is hidden, obscured by something, it gets notified that 1,000 changes and you don't bother to refresh until it gets exposed. And then you just refresh the most recent change, basically.
Exactly. Yeah. Right. So the question was, if you've got something off screen and it gets basically invalidated, the fields on that screen don't need to actually be updated until you make it visible. So that's exactly the case. So you're basically trying to minimize the amount of processing required. All right, so that's invalidation. So change listener, these are listeners that get notified when the value changes. So this is like after it's been recomputed, that's when the change listener. So you'll see the invalidation listener get notified first, hey, it's invalidated. Well, the change listener is not going to get invoked until the value actually gets modified. So these are at different times, and so the reason they're broken out like that between the two listeners just allows you to do the lazy evaluation. So down here you've got some other ones in the hierarchy. Read-only property, as you might expect, allows you to have a property that is read-only. And then down here at the very bottom you've got property, which is what you're going to be using most often. And this allows you to do the binding and unbinding. Above it, you've got just a binding class, which is essentially represents a value that is dependent on other observables. So we use all of these to some degree. Of course, we're usually using the derived class. All right, so some things to note here. Observable class, it's at the root of the hierarchy. Observable value encapsulates a value. Property gives you the ability to bind and unbind to other properties. And essentially an observable value, binding is an observable value that is dependent on other values. All right, so bind or not to bind. So if you call bind, that just creates a unidirectional binding between a property and an observable value. And as I alluded to earlier, once it's invoked, you can no longer call the set value method on the property that is bound, which makes sense because if you're basically saying this value property here is dependent on another property, well, that binding is then responsible for changing the value. Okay, so it would be kind of too much information, right? If you could just go in and set the value yourself, because that could break the rules of the binding. And the unbinding method basically just does what you expect and unbinds it. So if you unbind it, then you can call the set method again. And I showed you an example of bind bidirectional that creates the two-way binding. And one cool thing about the two-way binding is that it can have as many as you want. So you can do like two-way bindings between like one property and 15 others if you wanted to. There's no limit other than just the complexity of it all, which could get kind of crazy. So property classes. I showed you the hierarchy, which was just the base classes, which most of those you're probably not going to use directly a lot of times. So these are the ones that you're going to be using most often. By far the most common one is the simple property. And when I say type here, that could be like simple string property, simple integer property, simple long. So you just kind of fill in the blank because they have simple properties for all of your basic types. Those are the most common. They provide lazy evaluation, and those are appropriate for most situations. And then there is a property base. So if you want to do your own property, you would extend from these property base classes. Gives you a lot of boilerplate code, so you just saves you some time. Then there are these read-only wrappers. So if you want a version of a property that is read-only, you can just use one of these nice little wrappers here and it'll, boom, you've got a read-only version of a property that stays in sync with your original. So kind of a useful thing if you ever need that. Okay, so how do you create the bindings? Because that's going to be what we care about the most. There's actually 3 ways to create bindings. By far the most useful is using the bindings class. So if you've looked at the bindings class, it's got like 236 factory methods for creating bindings. You can do all sorts of cool things, adding, subtracting, multiplying, divide, and logical operations. So you can actually build up very complex bindings. There's also a Fluent interface, and it just, if any of you have never heard of the Fluent API movement, or I don't know what you would call it, but basically it's just allowing you to have a sequence of methods and to have it'll the operations read kind of like a sentence. So it's just a way of defining your methods. So there's a Fluent API provided by this expression. So you get, once again, plug in string or integer or whatever. That gives you this Fluent API. Now, I do have an example of these that I'll show you in a minute. So let's jump over to that. All right, so here's an example of computing the area of a triangle using your bindings utility class. Let me zoom in a little bit here. All right, so here we're creating lots of properties. All right, so you got x1, y1. These are the different points on the triangle, and we've got tons of temporary variables. All right, this is seems like it's pretty darn complicated, right? So we're calling multiply. It says, all right, we want to multiply these two guys together, and we're doing several of those. Now we're going to add, and then we're going to subtract, and then ultimately we are going to get the area, which uses the combination of all these things. All right, well that seems a little bit complex, right? Like, why can't it be a little bit easier? Well, this is where the Fluent API comes in terms of helping it be more readable. So let's take a look at the Fluent version of the same thing. All right, we still have properties for x1, y1 for our different points. Well, now we're just going to use the Fluent interface to do exactly the same thing. So we start off with x1. We call the multiply method, and then we can just stack them. You see how they're basically connected? So this is what the Fluent API does for you, which makes it much more readable. Because now we can just say, okay, x1 is multiplied by y2, and then we add that to x2 multiplied by y3, and so forth. And so ultimately, you get rid of most of those temporary variables and still achieve the exact same thing. So either one can be used in most cases. You just have to experiment and see which ones work which ones you like the best. Okay. All right. That's okay. Okay. So the last piece of this before jumping into some differences between Java and Swing and FX is talking about observing collections of things. So Andy didn't really mention it during the UI talk, but most of the several of the controls deal with lists of objects or sets of things. So if you think of like a tree widget, a tree view or a list view in JavaFX, well, those are dealing with collections of objects. Well, back in the Swing days, you would implement your tree model or your list model or whatnot. Well, in JavaFX, you don't have to do that anymore because they have these observable collections, which are really cool. But you basically get 4 different varieties here: list, map, set, and array. And these are pretty much the same interface as regular collections that you're used to, except that it supports an validation listener and also has type-specific change listeners. So when you modify one of these collections, it sends off an event that notifies you what changed, how it changed, very detailed in some cases. And so these end up being I guess you could say the models, the data models for several of the widgets in JavaFX for like list view, table view, and tree view. It makes things a lot easier to manage than, in my opinion, using the Swing model approach. So you can't actually instantiate any of these guys directly. So you can't just say new observable list. You have to use FX collections, and then there's a dot observable, insert whatever type it is, either list, map, or set. And so, like for instance, if I wanted an array list, I could say FX collections dot observable array list. And that would be how you instantiate the list. So you have to use FX collections class to actually create them. All right, so I want to talk real briefly about mixing JavaFX and Swing. I know kind of talked a little bit about it before, but you can go both ways here. You can do JavaFX in Swing. In order to do that, you have to use a JFX panel. So you can't just drop a JavaFX scene into Swing. You actually have to use a JFX panel, and that may be wrapped in something else. You could wrap a JFX panel in like a dialog, a JDialog, or a JFrame, or something like that. When you do that, the JavaFX runtime gets started automatically, so you don't have to worry about that. The thing that you do need to be careful about is that you're now dealing with 2 different threads. You've got your Swing EDT, and then you have your JavaFX application threads. So you have to be aware of that whenever you're running these 2 things simultaneously. If you use the wrong thread, it's going to mess something up. It's not going to be what you expected. So when you're dealing with JavaFX and Swing, anytime you want to do any kind of calls related to the scene or any of its nodes, you have to wrap it in platform run later, which is very similar to the event queue invoke later in Swing. But this is very easy to forget, and that will definitely cause you to have some weird artifacts on the screen. So you can also go the opposite way. If you want to do swing in a JavaFX app, you use a swing node. And one interesting thing here is that you only are supposed to use lightweight components, nothing from Java AWT, which means that if you try to embed a Joggle GL canvas in a swing node, you're probably not going to get what you wanted. And so it was just kind of a bummer, because it would be nice if they had like a GL node or something like that that would support it. You have to wrap any calls to swing in the event queue invoke later. Otherwise, you'll get weird results, just like you did with the other way around. And it may slow things down. Andy mentioned that, but really the bottom line is you got two separate threads running, and you're having to now communicate between them and synchronize between them, and that's going to introduce a certain amount of latency when compared to either straight up JavaFX or Swing. Okay, so that looks like all I've got there. Sorry, I had to go a little bit faster than I wanted, but any questions about that? Or about anything?
On the bindings, you were showing that you could bind sort of the built-in methods of the classes, the multiply, add, and so on. Can you have a class with some extended method like compute area of triangle, single method, and just invoke that, bind x1 dot compute area and feed it the other arguments, whatever?
Okay, so I think the question was, can you extend that Fluent API? Is that what you're asking?
No, even with the other, the pre-Fluent one, where you just had an example, and you were able to bind single expressions,
right,
single method invocations. Do those methods have to be these built-in, add, multiply, etc.?
No, they do not. They do not. And so what you can do actually is you can extend the binding classes. So here, I kind of maybe went through this slide a little bit too quickly, but there's a whole set of base classes where, like string binding or object binding, that you can actually extend and add, implement custom bindings.
Triangle binding.
Yeah. So you could actually take all of that binding that we built up using all the adds and multiplies. You could roll that into a single binding implementation, which you probably should if it gets too crazy. So they make that pretty easily. You basically only have to implement like one method to make that work. They offer several base classes that you can use to quickly build your own custom bindings if the ones right out of the box aren't sufficient. Okay, any other questions? Alrighty, well, thanks for coming out, and hope you got something out of it, learned a little bit more about JavaFX, and if you want to hang out afterwards and chat with us, feel free. Otherwise, we will catch up with you guys later. Go ahead and stop the feed here.
Just real quick.
Yeah.
Yeah.
I'm trying to remember what I did.